Good morning. Okay. So we are going to start class with a little exploration of octotonic collections, and then we will divert into the Bartók for the duration of class. Now, from Monday's video, you got an introduction into the octotonic collection, and one of the things that we talk about a lot in terms of the construction of that collection is two fully diminished seventh chords a half step apart. That's sort of one of the easier ways to like mentally construct it. Now, if we think about the whole tone collection, we had a very limited sort of color palette in terms of sonorities with that collection. We talked about that on Friday with the WC. You get augmented triads, and that's literally the only triad you can make, and you cannot make any complete seventh chords. So the collection is somewhat constraining in terms of just what sonorities you have to play with. Now we're going to contrast that with our possibilities with the octotonic collection. So I'm going to pull up one of the clock faces from the back of your packet. So I'm going to use a letter name clock face today. I know a lot of you are still getting accustomed to kind of converting PC sets into letters and back again. So I'm going to use a letter name clock face. I'm on page like 98-ish of the course pack if you want to grab one. So what I'd like you to do to start is just a quick little warm up. Can you just plot octotonic 0, 1 on one of these clock faces for me, please? Now, if you picked up on this on the lecture on Monday and the handout, this is a symmetrical collection. They're actually visually very easy. It's really easy to see the symmetry of these on the clock face because of the way it kind of parses out into those four pairs of pitches that are each a step apart. Okay, now what I'd like you to do is can you take a minute or so, and I want to see how many major triads you can find. So within this collection, how many distinct major triads are you able to build? Take a minute and play around with that. I'm still gonna do it. I highly doubt it, babe. Okay. So this worked way better with colors. You guys get like the non-tragic representation of this class. My 9 a.m. class just gets whatever happens. I fix everything by the time I get to your class. So what you see here, I kind of made triangles in different colors, but you can derive 4 distinct major triads from this collection. In essence, it's kind of the first note of each of these pairs can be developed out into a major triad. So then we have 4 major triad options. Now, can we do the same thing, but can you find as many minor triads as you can? Now, some of you might have already figured this out, but since the set is symmetrical, you really only have to work with one pair of pitches. Whatever you do with that pair, whatever you're able to do from that pair, you could do with the other four. So you can sort of reduce your workload to 25% by doing that. Now, we had four major triads, all built off of kind of the leftmost note of each pair. You can also derive minor triads from that same note. So we could go, for instance, C, E flat, G, E flat, G flat, B flat, etc. So four major triads, four minor triads, still only working off of four of the notes as roots of those triads. Now, I'm not going to, I don't think, take away from your learning by spoiling this surprise, but since this collection is constructed of fully diminished seventh chords, it stands to reason that you can build a diminished triad off of every single one of those pitches. So we have then the possibility of 8 diminished triads. You cannot build any augmented triads, so in that way it is the complete reversal of a whole tone collection. You have no augmented options. So already we see that we have a really varied palette of possibilities for triads. That also extends to seventh chords. Now again, the set is constructed of fully diminished seventh chords, so you could build one off of every note. But let's take this major triad that we built off of, I'm going to arbitrarily choose C, C to E to G. If I want to turn that into a seventh chord, I actually can by shooting it up here to the B flat. So C, E, G, B flat. I can also build a dominant quality, a major minor seventh chord, off of those same sort of first note of each pair. So that gives us 4 major minor seventh chords. And since B flat would also be the root of would be the seventh of a minor minor seventh chord built off of C, and we know that we can create that, so C to E flat to G to B flat, we can create 4 minor minor seventh chords. Now this doesn't even touch on incomplete seventh chords. So there are even more options if you go that route. But just by this quick little 10-minute exercise, we found that the octatonic collection has tons of possibilities in terms of the types of sonorities that you can create with it. Now, any of you who are doing the Rimsky-Korsakov for your capstone project, he takes this idea and just runs with it. So there are these extended octatonic passages that for a lot of it you wouldn't even know were octatonic because he doesn't really exploit the melodic aspects of it. It's just color palettes of moving from the major triads, moving from one major triad to the dominant seventh chord, all within the collection. So he exploits the octatonic collection in a very specific way. And today we're going to hear how Bartók exploits it in a very different but also very specific way. Okay, so let's go ahead and grab our Bartók scores. And we're going to take a little listen to this piece. I saw a bunch of free writes come through. I've gotten to some of them. So for a lot of you, this is a multiplicitous listening. For some of you, this might be your first time. Let's just take one rad through it without saying or doing anything. And then we're going to take a more specific listen. So here it is one time for you. pencil, and I would like you to mark as you're listening this time. And I just want some formal labels. So mark the form in any way that makes sense to you, and we'll come up with some labels after this listen. So here's one last time. All right, I'm going to put my form labels on the class score. If you have anything that is significantly different, we'll chat about that. I'm guessing we're all going to be pretty much in line with one another. I'm going to arbitrarily call the opening A, and at measure 6, I'm going to call that B. I'm going to give 15 a label of A prime, and then measure 20 I'm going to call B prime. These last 4 measures, so right at the tempo primo where we return to 3/4, I'm going to refer to it as a coda. I am guessing that some of you might have some sort of like A-ish label there because it obviously uses material that is derived from A. So if you have something like that, that is totally fine. And we'll talk about that in the last couple of minutes of class. But my guess is that we're all pretty much in line in terms of these formal areas. And I'm going to just add it here. You're just missing a time signature in measure 11. I've been teaching off the score for years, and I didn't notice it until someone brought it up last hour. So you're missing a time signature, sorry. Now, you have already been introduced to the octatonicism at play in the opening 5 measures from the video lecture. So we know that the opening, we are dealing with octatonic 2/3. But I want to talk about specifically how Bartók manipulates that collection. So I'm going to renotate the PC sets on here. I know you did this in the lecture video, so I'm not going to make you do it again, but I am going to put the pitch class sets, the pitch class intervals, integers on the notes on the score so that we can sort of see what's going on. So we've got 8653 in the second voice, and the first voice we have 9, 2, 0, and 11. Now, that is the only pitch content for those 2 voices for their 5 measures. So each voice has its own respective tetrachord. They do not share any notes. There is no crossover. Each voice lives in its own tetrachord. So I'm going to take that tetrachord of the first line of the top line, reorder it from lowest to highest, and this is what it sounds like. So to me, that sounds like 1, 2, 3, 4 of a minor key. So we've got the first 4 notes of a minor scale in essence. And because of this phagogic accent here and the other one here, I'm pretty comfortable saying that this is a PC9, an A-centric line for those 5 measures. I would pick A as my centric pitch. I'm going to try and avoid using tonic as my word. Now, let's take the 4 notes, the tetrachord for the lower voice. I'm going to again reorder them, and it sounds like this. Which also sounds like 1, 2, 3, 4 of a different minor key. And if I were to, again, pick a centric pitch for this line, I would go, partially again because of the agogic accents, we rest on PC3 an awful lot. So I would choose then D sharp as my centric pitch for that second line. So I'm going to put the PC integers above these real quick. So we've got 9 and 3. So the interval between them, I see 6, the tritone. So we have 2 lines that are working basically independently of one another in some degree. Their centricities are a tritone apart, and each line lives in its own little tetrachord. If we were in real time, I would absolutely 100% make you guys sing this in 2 parts. It would be really, really fun. It's shockingly difficult initially until you sort of get the feel for it, but it's a super fun way to kind of live in that dissonance. Okay, so there's our A section. Looking at and recalling the sound of the B section without even mentioning octotonic collections. I don't even want to hear about it for the moment. What distinguishes the B section from the A section? Other elements. So throw them in the chat or speak up. What are the musical elements outside of octotonic collection content that distinguishes the B section from the A section?
Faster tempo and louder dynamics.
Tempo, good. Yeah, tempo, dynamics, accent, style, articulation, rhythm. Good. This is great. Totally different mood, aggressive, vertical. I like that description. Yeah, time signature, repetition, much more square rhythmically. I like that description too. Good, 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 good. So some of you even wrote in your free write something to the effect of like, when you were listening without the score, the downbeat of measure 6 was almost jarring. Like if you're not expecting that big of a shift, it's very drastic and can be a little startling for your first listen. But there's a huge affective shift. Now, let's talk like theory 1, 2, 3 content. It's somewhere in those first 3 semesters. If you were to describe measures 6 to 14 to me in terms of their form or their kind of formal element or stylistic element, how would you describe what's going on from 6 to 14 in layman's terms, in early theory terms?
Canon.
Yeah, good. So these 2 lines, good, imitative canon. So they're in canon with one another. Now, when we describe canons, we usually use 2 specific descriptors. One is the time interval, so the number of beats between entrances. So we've got, in this instance, it's very clear, full measure of rest. So our canon is at the half note. And we also use a pitch interval to describe the interval between the voices. Now, most canons in super consonant times are usually like at the octave. They might be at the 5th. Can we take a few seconds and can you, for me, put pitch class integers, so PC integers, on the first note of each of the voices, mind the clef and the key. So on the uppermost voice, we're in treble clef. We have a D, so it's PC2. And then our second voice, we are in alto clef, and we have a G sharp, which on your clock face or in pitch space gives you PC8. So simple math, 8 minus 2 gives you interval class 6, which, if we refer back to our A section, was also at IC6, also at the tritone. So our canon is at the half note for time interval and at the tritone for pitch interval. Now, what I would like us to do, there is one other distinguishing feature between these sections, and it has to do with the octatonicism. So can you, for me, go through the B section, so measures 6 through 14, and can you put PC integers on all of the unique notes? So there's tons of repetition. I just need to know unique PC integers. And once you do that, I'd like you to map them onto a clock face and or figure out which octatonic collection it is in whatever way makes sense for your brain. So take a couple of minutes and work through that, please. All right, I have the PCs written over the notes. So I have 2, 5, 7, and then a 4 at the very end of the first line. And then the second line, you've got 8, 11, a 1, and then again, the penultimate note is a 10. So again, parsing out these tetrachords, which we'll talk about in a second, but let's get the collection first. So I made a little homegrown clock face over here, so I'm going to plot all of these. So I have a 2, 5, 7, and 4. And then I have an 8, an 11, a 1, and a 10. Just by eyeballing that clock face, you can immediately see the octatonicism. So then it just becomes a matter of labeling it. So our first half step becomes our label. So that means that we are in octatonic 1, 2. So not only do we have all those other beautiful musical factors you mentioned in terms of articulation and tempo and rhythm and all of that, but we also have switched octatonic collections. Now, I'm going to go up to the opening again, and I'm going to really quickly put octatonic 2, 3 on a clock face so that we can talk about this very specific way that Bartók has chosen to partition his collections. Now, if you look at measures 1 through 5, we talked about how each voice has its own tetrachord. Each voice has its own 4 notes. Probably the most logical, I might think, way to divide the octatonic collection into two tetrachords would be two fully diminished seventh chords. Bartók doesn't do that, though. He takes a different approach to this division of the collection. Instead, what he does is he takes this uppermost voice, 9, 2, 0, and 11, and then our second voice gets this tetrachord. So he pretty much bisects the clock face through a central axis and just gives 4 notes to you, 4 notes to you. Now, let's see what he does with octatonic 1, 2 for the B section. If you have this on, if you already have a clock face sketched out, this will be really easy for you to kind of draw in. But our top voice, 2, 5, 4, and 7 is right here. And then our second voice is right there. So again, he takes the octatonic collection and just sort of, through an axis of symmetry on the clock face, just parses it out. You get 4, you get 4. No real explicit exploitation of the fully diminished sonorities that build the collection. It's more using the minor sound of the minor tetrachord to derive it. Okay. Good, we're right on time. So now, again, without mentioning anything octatonic-y, using your other 3 semesters of theory vocabulary, how would you describe A prime as it relates to A? What happens to A prime? What makes it different from A? Yeah, Miriam.
I just noticed this, and as we were listening to it in class, I didn't notice during free write listening. But it's an inversion, which is very Bartók to do.
Yeah, good.
It's super cool.
Yeah. So A prime is an inversion of A, and it's kind of a double-barreled inversion. So if you look at A versus A prime, so A, we have those 2 very distinct individual lines. Look at what happens to them in A prime. They switch spots. So the line that the uppermost voice had, the first violin or first viola, depending on what recording you listen to, now is in the second part. And the second part takes the first part. So we do a part inversion. But let's also look at the individual lines. So let's focus in for right now on the second viola part of the opening. And more specifically, I'm going to zoom us into, let's just look at the first 4 notes for right now. If I were to ask you in class to describe the contour of that, most of you would say it's going down by step. Stepwise downward contour. A prime, now that has moved up to the first viola part, now look what it's doing. Stepwise upward contour. So not only have we inverted the voices, but each line has undergone its own inversion in terms of contour. Now, there are lots of ways that we can talk about inversion to make it kind of more specific. We are going to, in the next 10 minutes or so, take a crash course in describing inversion as it relates to pitch class sets. And this is something we will come back to on Friday, and you have a worksheet for it that you can do in the interim. But we are going to figure out how to specifically describe this inversion that's going on between A and A prime. So let's look at those 4 highlighted notes in each part. We have PC integers on these opening 4 notes. Can you put PC integers to these other purple highlighted pitches for me? The first 4 notes of viola 1 and A prime. Can you put PC integers on them, please? So you should have 5, 7, 8, and 10, or T for your PC integers for those 4 notes. You have F, G, A flat, and B flat. Now, if we are trying to figure out specifically how these are inverted, and by specifically how, I mean that we have to, when we're inverting, a lot of times we think about inversion as coming from the same pitch. So I'm starting here. I had a line that went this way. Sorry, I just scared my husband. So we're starting here, and say we had a line that went whole, half, whole. It's really easy to invert around the same note, right? And we go down, whole, half, whole. But we're not starting at the same note. We've also transposed it. So we've got to figure out how to describe this inversion. And we are going to do that, I apologize in advance, using some math. So what we're going to do is we're going to buddy up all of these notes. So by buddy up, I mean that PC8, once it was inverted, turned into PC5. PC6 turned into PC7. 5 became 8. 3 became 10. So I'm going to write both of those PC collections on top of one another. So I've got 8, 6, 5, and 3. And they became 5, 7, 8, and T, or 10. So again, the important part is that you are pairing up each note with who it became after the inversion. Now, here's the math part. We're going to do some mod 12 addition, but still keeping those columns. So what I mean by that is 8 plus 5 in mod 12 world. So 8 plus 5 in regular math is 13. But since we're using mod 12 math, 13 is bigger than 12, so you've got to subtract 12 from it. So then it becomes 1. Six plus 7, also 13 in regular math. Mod 12 math, subtract 12, it becomes 1. Keep on going. 5 plus 8, also 13, also becomes 1. And 3 plus 10, 13, becomes 1. So, this is not coincidental. Every single one of those operations gives you the same mathematical reaction. You get 1 in mod 12 world for all of them. What that means is that is our specific inversion axis. Now, on Friday, I'm going to give you a really cool handout that shows all of the possible axes of inversion. All you have to know right now is this tells us that we have inverted around the axis of 1. What that means is, I'm going to jump back to a clock face really quickly. PC1 is this guy, right? So inverting around 1, you do that math thing and you get 1 as your answer, means that we have put an axis of symmetry through PC1. And so imagine sticking a mirror there. That's what it would reflect back. So that is your axis of symmetry. So that means that you have these kind of pairings over the axis itself. So if we're thinking about inversion, then you could invert through any of these axes, right? You can invert through this one, you can invert through this one. All that little bit of math did was tell us where our axis of inversion is. Now, I said this in my last class too. We're going to do a lot of like small group practice on this on Friday. So if that felt really chaotic and way too much information, There's a worksheet on this that will walk you through doing the same exact thing for this line. So you're going to use this tetrachord and figure out how it inverts there. And it'll walk you through step by step. You can submit it for points on Friday, but there's plenty of practice we're going to take with this. This is just a really, really clear instance of inversion, so it's a great model for it. So all that is to say that A prime is a part inversion as well as a pitch inversion of A. Now, B prime has a couple different things going on. So if we look at B versus B prime, we have, again, this inversion of the parts, right? We could refer to this as Dukes and Comus if you want. I don't know how many of you even did the canon and fugue unit in Theory 3, so I will not utilize those terms very much. But we do invert the parts, and we also invert the contour as well. So both of the primes have distinct relationships to their originators. The last thing I want to talk about, we have just enough time, is this coda. I want to listen to this piece again. I want you to focus in on the coda and think about its particular sound. So this entire piece is this wash of octatonicism. We do switch collections. I want you to sort of, once you're inundated with that sound for 28 measures, I want to know what those last 4 measures sound like to you. How does the coda differentiate itself in terms of sort of its aural perception? So this is from the beginning. Oh, maybe not. Did I turn all my sound off? Sorry. Shush. Okay, my sound's not working anymore, so I guess never mind. I hate Zoom so much. All right, so since we can't listen to it, I'm going to play. This is going to be chaotic. I'm going to play just this part right here, and I'm going to stop at the end of measure 26, 7, 8, 9. So the coda-ish begins here. What do the voices do for the first time and the only time in this entire piece? Look at what we have going on right there. So I'll play it for you again. You can slap pitch classes on it or letter names or whatever. But again, this is what the measure 29 sounds like. So we've got E flat in the upper voice. Our voices, for the first time in the entire piece, yes, they share a note. They haven't shared a PC set, a PC integer at all in their distinctive parts. So every time that we get a new section, each voice has its own distinct tetrachord, and there is no overlap. Bartók parses out the octatonic collection each time, but there's no overlap between them. So each voice has its own unique tetrachord. When we get to this coda, we get a pitch overlap. Now, can you, in the next minute or so, can you put PC integers on the coda? So again, it's repetitive, so you don't have to do every note, but do enough so you get the whole collection. so each voice has its own tetrachord still. The upper voice has PCs 3, 5, 6, and 8. And the lower voice has PCs 1, 8, 10, and 11. Each voice still maintains a tetrachord of distinction, but the tetrachords share a note. So we're not in an octatonic collection anymore. We're in a collection that has 7 distinct notes. Now, we are very familiar with collections with 7 notes because our entire diatonic system is built off of them. So, with that in mind then, you can clock face this if you want, or you can just letter name it. And I want to know what collection we're in. So you've got 2 tasks then. Figure out what notes you're dealing with. And figure out who the centric pitch is. That's going to affect your label for this passage. But clock face or letter names or something else to figure out what pitch collection we have. And then once you have decided on a centric pitch, I want to know how you would label this passage. Okay, I'm creeping on the chat. So we have 2 discussions going on, or two different threads. We have some Aeolian and some Dorians. And so both of these discussions are relying on the same pitch content, which is really interesting. We're differing by centricity at this point. So I wrote down letter names down here in no particular order. I think I just went top line, then bottom line. And I did clock face them over here. And the reason I put them on a clock face is because it explicitly shows you where the half steps are. And it also makes it really clear that we're not in an octatonic collection. We have 2 pairs of half steps. So that's a good indicator, again, that we are in some sort of diatonic world. Now, a lot of this discussion now that's going on in the chat is in regards to who the centric pitch is, I think, more than anything else. So our pitch content remains the same. So my Aeolian people, I'm guessing, are hearing E flat as the centric pitch. If I take this pitch collection and I decide that E flat or PC3 is my centric pitch, if that becomes scale degree 1, then my half steps are between 2 and 3 and 5 and 6, which would give you an Aeolian collection, or natural minor, however you want to think about it or hear it. Now, I also see some discussions of Dorian going on in the chat. So let's also talk about that. So some of you are hearing A flat as the centric pitch, and that is coming from the fact that A and A prime, we were talking about two different centricities occurring simultaneously, right? So we had top line has its own centricity, bottom line has its own centricity, and that was just how they were. Now we're in an instance where the material is almost exactly the same. They both have the same kind of content as A and A prime. Do they still have their own independent centricities, or have we kind of meshed them both together? So if we were looking at this second line by itself, that would be our centric pitch. We would say it's A flat centric. If we were looking at the top line by itself, we would say that's the centric pitch. It's E flat. So now we've got them both occurring together with the same collection. So what do we do with that centricity? And I don't have an answer for that. That is a sort of listener's choice, choose your own adventure response. I think a lot of it is going to rely on which line you hone in on. So some of you might distinctly hear this as an E flat centric passage in its sort of gestalt overall. And some of you might hear the entire passage as A flat centric. And that is totally, both of those options are absolutely valid. So that's a great, leads me to my last point. That's great fodder for your discussion response. If you would like to submit one for this piece. Other thoughts in terms of discussion response? We didn't go through and see what octatonic collections we're using in A prime and B prime, or how they're parsed out. So that's a good little diversion to figure that out and compare it to A and B and see how Bartók continues kind of manipulating his collections. Does he omit a collection? What does that tell you? Why do you think he might have done that if he did? So those are great little discussion pieces for your response paper. The last thing we're going to do, this is very important. Very important question in my household right now. So,
Can we add another option to this?
what is it? You don't eat tuna salad because it's gross?
Yeah, that.
I did this poll on Instagram last night too. I got the same response from several people. Jake, where are you from?
I haven't eaten any tuna salads, but every one that I have includes grapes. Oh, Minnesota.
Minnesota. Okay. I'm wondering if it's a regional thing, because the backstory on this, and you guys can leave. It's 11. You can leave if you want to. I asked my husband to get me tuna salad stuff the other day at the grocery store, and he asked if I wanted grapes too, and I was horrified. I had no idea what he was talking about. I'd never in my life heard of this, and he grew up in the Midwest, and I grew up on the east, in the Northeast. So I wasn't sure if it was regional. My other yes people, where are you guys from? Because I'm very curious if it's a regional thing. Yes, I have seen it in chicken salad. I've never actually eaten it in chicken salad, but I have seen it. But I had never heard of it in tuna before. Okay, well, babe, it's 12-3. The no's have it, but I do have some yeses.
And I still have the yes from a chef. So
my husband's hanging on to the fact that of the 3 yeses I got on Instagram last night, one of which was him, another one was our friend who's a chef. So in his mind, that counts for 20 no's. All right, thank you guys for answering that very important question that I had. All right, your capstone projects are due on Friday. If you have questions, let me know. There's no pre-listening for Friday. We're going to take it easy. We're going to practice inversions in groups. We're going to listen to a piece that I think will be new to most of you. It has an octatonic passage that is so vastly different from the way Bartók utilizes octatonicism that it'll be a really nice sort of comparison. But no free write for it. It's just kind of an easy listening class. Get your capstones figured out and submitted. Email them if Blackboard's being a turd, which it probably will. And I will see you guys on Friday. Thank you so much.
Thank you, Professor. Thanks.
Thanks.